Hello, everybody, and welcome to the second lesson of this week. And this week should be that starting April 20th, I believe. So hopefully, this is the second one you're doing this week. That is kind of part of the schedule that I put up on Brightspace. So today we are going to go over some compound interest information. We did talk about this briefly in cycle one. If you remember, we did some simple on and compound interest questions, but I wanted to go over it a bit more because there was some confusion with how to find the number of compounding periods as well as how to find the interest rate. So we're going to go over that. So our learning goal today is to demonstrate an understanding of compound interest. We're not going to do any problems today. It's really going to be just setting up the math and practicing the calculations. Okay, this is going to be a bit of a review first. So we're going to talk about simple and compound interest. So simple interest is interest just earned or paid only on the principal amount that was invested or borrowed. So that's the original you put in. So say if you borrow $500, you're only paying interest on that $500. The equation for the interest charged on a investment or borrowed is given by this equation. I is the interest that you will calculate. So either that you earn or that you pay, depending on if you invest or borrow money. P is the principal. So that's the money you are borrowing or the money that you're putting into an investment. So the original amount. The R is the interest rate as a decimal. Remember, if it's 5%, you need to divide that by 100 to get it as a decimal. That's a very important step. And then T is the time it is put into an investment or how long it's borrowed for. And that has to be the same period as the interest rate. So if the interest rate is annual, so per year, then the time variable T has to also be in years. Okay. Now, if we want to find the total amount out of investment, you can imagine that the total amount is the original amount, the principal, plus the interest that you earn. That's the same if we borrow. The amount you will owe would be the amount you borrowed plus the interest charged. And that was caused a little bit of issues on the cycle one test, question number 3, I think. I'm going to post those solutions to the Brightspace soon. I've sent it to some of you. So I'm going to post the solutions to that test soon so that you have it available if you want to look through it. Okay, compound interest is interest that is added to the principal before new interest earned, or what's the opposite of earned? Paid. There we go. Earned or paid is calculator. So interest is calculated on the principal and then plus the interest. So for example, if you borrow money for 5 years, you'll get charged interest 5 different times. And each of those amounts of interest will increase. So in this case, interest is paid at regular time intervals, and those are called the compounding periods. Here's the compound interest formula. So if we want to find some amount in the future, using the amount we invest or borrow, so that's the original amount, 1 plus I is our interest rate, and that's per compounding period. And we're going to go over that again because I think that caused some confusion last cycle. Remember, that needs to be a decimal. And then N is the number of compounding periods. so this is the equation to find, how much an investment might be worth after a certain amount of time. If we want to find how much do we need to invest to get to a certain amount in the future, we can rearrange this equation for P. So how much do we need to put in or how much do we need to borrow? And we're going to do that probably next cycle. I just wanted you to see those two equations on one slide. Okay, let's take a look at how in the world do we get the proper I, so our interest rate, and our proper N from the information that we're given. So this is a beautiful table to figure out how to do this, okay? So if the compound period is annually, your interest rate will equal the annual interest rate. And we're going to do some examples on the next slide. So if this doesn't make sense quite yet, I'm going to go through this though, and then we're going to do some examples. So because all of our interest rates are given as an annual interest rate. So if it compounds once a year, then your interest rate is just your annual interest rate. And because it's compounding annually, the number of compounded periods is just how many years you're investing for. If it's semi-annually, now your interest rate is going to be divided by 2, because remember, it's going to have, if it's a 2% interest rate, that's going to be an annual rate. So that's for the whole year. But if it compounds twice a year, you're going to divide that interest rate by 2. Okay. On the other side, because it's semi-annually, you're going to have 2 compounding periods for every year that you're investing. So that means to find your compounding periods, you have to take your number of years you're investing for or borrowing for times 2. Okay. And it's going to be the same thing as we go through these other compounding period types, depending on basically how much is this compared to 1 year. So quarterly, you can imagine we have to have 4 compounding periods per year. So your N is going to be the number of years times 4, because there's 4 quarters in a year, right? And so you're going to divide your annual interest rate by 4 to get your interest rate that you'll put into the equation. Monthly, well, there's 12 months in a year, right? So that means every year there's going to be 12 months. So you're going to find your compounding periods by multiplying your number of years by 12. And your interest rate is going to be your annual interest rate that you're given in the problem. Divide that by 12. If it's weekly, there's 52 weeks in a year. So your I, that should be a little lowercase. You're going to divide that by 52, and your N, you're going to times it by 52. And finally, daily, that is not a real thing. I've never seen that in real life, but sometimes it comes up in math, or if you're like a really mean friend, you can charge interest daily. Daily, there's 365 days in a year. So your I, you're going to divide it by 365, and your N, you're going to multiply it by 365. Okay, let's do some examples with that. And again, I'm going to type in here like I did last time. So hopefully this isn't too ridiculous, but whatever. Okay, so here's some examples. We have an investment at 5% per annum. So our annual rate is 5%. It's compounded annually. So that means it's compounded once a year for 3 years. Well, if we go back to this chart, if we're annually, our interest rate is just equal to the annual interest rate. So I'm going to copy that. Copy. I'm going to put that here. So therefore, I must equal to 5%, which, don't forget, we have to divide that by 100, which is 0.05. Remember, to divide by 100, you're just going to move your decimal point to the left by 2. So there's our annual interest rate. Number of compounding periods. Well, if it compounds once a year and we have 3 years, well, 3 times 1 is 3, right? So, because remember, if it's annually, your N is going to be equal to the number of years you're investing or borrowing for. So that means N is 3. Okay, so that one was easy because it was annually. You just take the numbers out of the question. Don't forget to change that I, though, to a decimal. Okay, now let's say we're loaning money at 6% per year, compounded semi-annually for 2 years. So let's go back to our semi-annually chart. So semi-annually, you're going to do annual interest rate divided by 2. So our annual interest rate divided by 2. So I is equal to 6% divided by 2, which is equal to 3%, but don't forget we need to write that as a decimal. Okay, now what about number of compounding periods? Well, remember, compounding semi-annually, that means we're compounding twice a year, and we're doing that for 2 years. So remember, you're going to multiply the number of years that you're compounding for by 2. So N is equal to 2 years. 2 years times 2 is equal to 4. Okay, I'm going to make this smaller so it doesn't like go all crazy on me here. That's right, go all crazy on me. I hope you guys are enjoying these videos. Okay, loan. This is like a credit card. Loan at 25% per year, compounded monthly for 3 years. Okay, monthly. Let's go to monthly. So our monthly, remember our interest rate, you're going to divide that by the number of compounding periods per year. So our interest rate is 25% divided by 12, which equals to, well, let's see, I'm going to use my calculator. 25 divided by 12 is 2.08. 2.08%, but remember, divide that by 100, 0.0208. Okay, and I'm going to make this smaller so that it fits. Okay, and then number of compounding periods. Well, if it's compounding monthly, that's 12 periods in a year, and we're doing it for 3 years. So if we go back here, that makes sense because my N is going to be number of years times by 12. Okay, so we have 3 years. 3 years times by 12 equals, what's 3 times 12? 36? 36 compounding periods. Okay. So let's do this last one. Same thing. Okay. So investment now, 2.1% per year, compounded daily for 1 year. Okay, so if we're doing daily, we have to divide that by the number of days in a year. So that's 365. Yes, I know it's 366 for a leap year, but we're going to do this on average. If you want to be specific, you can divide it by 365.25, but you don't need to. So what's our interest rate? So that's 2.1% divided by 365 equals, so 2.1 divided by 365 is 0.006, we'll say, percent, but don't forget we need to divide that by 100 to get the daily interest rate, which is like ridiculously small. So 0.12346. Okay, because that's what you would put in for I, okay? Because remember, we have to convert the percent to a decimal. Okay, N is the number of years times 365, because there's 365 compounding periods every single year. Now, this is only 1 year, so that means it's just going to be 1 year. Oops. 1 year times 365, and 1 times 365 is 365. So for your N, you would put in 365. Okay, so I'm going to make this all red, so when you go and look at it later on, you can tell that that's the solutions. Oops, and I was supposed to do that, so I'm going to do it like that. Blah, blah, blah. Okay, so that's it for the lesson. What I want you to do is complete the 2.12 practice questions. The solutions are on the page. And there is no quiz for this one. Yay! I figured because this is a review, I didn't want to do a quiz on it, to be honest. Here is the assignment, not assignment, the practice. It looks like this. So for the question 1, you're just going to do exactly what we just did in the table. Just so you know, conversion period, that just means compounding period, okay? And then number 2 is basically, can you use your calculator to get the right answers? So the answers are down here, so make sure you can put these into your calculator properly to get the answers down here. And the last question is just definitions. So that is it for this lesson. No quiz. So I hope you enjoy your week or weekend. It is a PD day on the Friday. What is that, the 24th? Yeah, so enjoy your long weekend, I guess. And I will talk to you again soon. Okay, bye guys.